Assalamualaikum warahmatullahi wabarakatuh. My name is Nurku Azizi binti Zorani and my supervisor, Associate Prof. Shazaiba binti Muhammad. And my study title is a study of astaxanthin production in a Coelastrum species. For the introduction, astaxanthin is the strongest carotenoid antioxidant which only can produced by microorganisms and plants. It became highest demand in the market, especially in nutraceutical and cosmetic products, pharmaceutical, and valuable in the food industry. H. pluvialis become one of the potential microalgae due to the richest accumulation of high concentration of astaxanthin. There is one more type of microalgae that have same potential production of astaxanthin from natural sources, as this genus is mostly similar to the Haematococcus pluvialis, which is Coelastrum species. Both types of microalgae can undergo two stages that have been studied in two different objectives, where the green stage is for the photosynthesis process, while astaxanthin accumulation during the red stage. Extraction process play important role to obtain the pure and natural astaxanthin from the microalgae. Next, for the problem statement, H. pluvialis grow relatively slow with a low biomass yield, easily polluted by other fast-growing species and vulnerable to high hydrodynamic stress. Next, the extraction process faced the difficulties with highly physicochemical resistant cell wall of the microalgae. So there are two objectives for my studies, which first one is to study the effect of stress condition in pH medium, highlight intensity and nitrogen starvation in the two stages growth condition, which are green stages and red stage in Coelastrum species, with H. pluvialis as control for both growth and astaxanthin production. Second is to identify the most suitable method for astaxanthin extraction from the Coelastrum species. Next, the scope study is to determine the growth curve and the production of astaxanthin of Coelastrum species by introduce the stress effect, which are pH medium with pH 3, 4, 7 and 9, and the nitrogen starvation between 0.1 until 0.3 gram per liter, with the H. pluvialis as a control on the first stage of microalgae, and then it continue with the highlight intensity, which 250 to 450 micromole photons for the second stage. The last one is to select the most suitable type of solvent to be used as a pretreatment and extraction method. So the methodology, firstly we culture the microalgae strain and undergo first stage with the stress condition pH medium and nitrogen starvation, and the second stage with the highlight intensity. Next, extraction of astaxanthin, and the last one is analysis of astaxanthin. Result and discussion. Based on the first figure here, showing the result of the growth curve of Echinodermus obliquus that been successfully recorded the optical density OD for 30 days with the constant interval days at which 3 days. The growth curve started with a log phase at the initial stage until it achieved the optimum growth at the 15. Then it started to reach the exponential phase. Next, based on the second figure, it showed the pH medium can affect the production of carotenoid. The natural pH of the culture medium is the best for growth, astaxanthin production, and content. As you can see here, for the pH 10 and the pH 3 is the lowest optical density with comparing the other pH. It proved that the microalgae cannot tolerate with a very high or very low pH. Instead, it can grow at the optimum pH cultivation. For the nitrogen effect, it can change the cell size, density, and morphology. So, it can enhance the growth during late culturing and postpone the formation of the enhancement stage of H. pluvialis. At the initial cultivation, it only minimal amount of nitrogen sources needed rather than second green stage in order to achieve the maximal growth. Next, nitrogen depletion can enhance the accumulation of astaxanthin. The nitrogen starvation can inhibit chlorophyll biosynthesis and favor chlorophyll B degradation, chlororespiration, and cyclic electron transport, whereas cell growth in a high light. As you can see in the figure below, it can prove that the production of astaxanthin in the highlight and nitrogen was lower without rather than without nitrogen. This is the reason why nitrogen sources more preferable added in the first stage. The highlight effect. Firstly, the formation of vegetative stages to the assessment stage would be triggered when any factor interfere with the cellular process that limit the growth or photosynthesis. It leads to high concentration of biomass and considered an important factor to increase the production of astaxanthin. It's related to the enlargement of cell size, as you can see here. For the green stages, is more smaller than the red stage. The non-motile cells were more favorable to this development of large astaxanthin-rich cysts than motile cells. Lastly, the extraction of astaxanthin. Haematococcus pluvialis is accompanied by the synthesis of rigid cell wall. So, the extraction process faces the difficulties with the highly physicochemical resistant cell wall of the microalgae. So, to overcome it, two steps need required, where the first step is hydrolysis and the second step is liquid solid extraction. Hydrolysis with the hydrochloric acid to remove the chlorophyll to produce pure astaxanthin or cell disruption, and solvent extraction with the acetone, which more effective due to high water soluble that can easily permeate the cell wall of microalgae. In conclusion, the stress condition that be introduced is pH cultivation medium, high light intensity, and nitrogen starvation give an impact on the two stages of growth and astaxanthin production in microalgae. The pH medium preferred in a natural medium, and nitrogen starvation and the light intensity do affect the growth and astaxanthin production with a certain level of light intensity and concentration of nitrogen sources. Nitrogen starvation was more favorable in the vegetative stages, while high light intensity can enhance the production of astaxanthin in the enhancement stage. Lastly, the extraction process more suitable and effective by using hydrochloric acid as a pretreatment, followed by acetone as solvent extraction. Lastly, this is my reference for my studies. Thank you for listening.